record. All right. So on that hypothesis testing, each time you're going to be given a situation. Good morning, Coach.
Hello. You want to sign Larry's birthday card?
Yes, I do. 1 second, my friends. Oh, you're all right. Oh, that's awesome. You I got a new job next year.
Huh?
I'll be the math master teacher leader for math for here,
Okay.
but I won't be in the classroom.
What are you gonna do? Home?
No, here around just helping other math teachers
Oh,
and
sweet.
students and stuff. So I won't
Do
have
you want to do
classes.
that?
Yeah. So I'll be here. I just won't be. Thanks. See ya. Okay. Sorry. So if you open up, you have that worksheet, Miss Jessica. Let me turn on the pin. All right. So hypothesis testing, you are given a situation where somebody has made a claim. Their claim is that 69% of all high school seniors enroll in college after they graduate. So our null hypothesis is that P equals 0.69. That's their claim. Hannah believes the number is too high. After surveying 88 seniors, she finds 54 of them enrolled in college. Does her evidence at a 95% confidence level show that 69% is too high? So she believes that P is less than 0.69. P hat just comes from her information. She found out that 54 out of 88 seniors plan on enrolling in college, and that's where we can pull up graphing calculator. 54 out of 88 is 0.61. So 0.61 is your P hat. To get the standard deviation formula, just remember that standard deviation is based on the P value, not P hat. So it'd be 0.69, 1 minus 0.69 over the number that was in the sample, 88. So it's the SQRT, if you want to type it out, divided by will give you that fraction, 0.69, 1 minus 0.69. No, I didn't even ask yesterday. You guys do see that calculator when I pull that up on the screen, right?
Yeah.
Okay, good. So 0.0493 is your standard deviation. So 0.0493 you then need to convert into a z-score, which to get the z-score, you do your p hat, 0.61 minus p, which is 0.69 over the standard deviation. So what's going on is that Hannah only interviewed 88 people. So did she do enough? It did come out much lower than 69%, but is that enough people to show that this 69% is false? So this z-score is going to give us what we can type into the normal distribution. So back to the calculator. Fraction 0.61 minus 0.69, 0.0493, and you get a negative 1.62. Negative 1.62. Our alpha value, since you want a 95% confidence interval, that means alpha is 5%. It's the rest of it, right? It's 1 minus 0.95. Remember, if your p-value is less than this number, then you can reject the null hypothesis. So we need the calculator with a 0.162 to get, or negative 1 point to get that. So that's when you do normal, BIST, 0, 1 for these. And find the probability, since it's negative, that's going to be your maximum, negative 1.62, and that's 0.0526. So this p-value, 0.0526. And that comes from doing normal distribution 0, 1, and negative 1.62. Yeah. That's negative infinity. You leave negative infinity in your left and your lower end. So since this number is bigger than 0.05, then we say we fail to reject. So remember, there's only two things you can do: reject the null hypothesis or fail to reject the null hypothesis. So it doesn't mean that the null hypothesis is right. It just means that she didn't get enough in her sample to prove that it's wrong. Because this is definitely well below, but if her sample size is 88, that's not enough. What's that? The 69%? Oh, 0.05, that if the p-value is greater than your alpha value, then you fail to reject. If that p-value is less than, then you can reject it. So, any questions on that one? So the quiz pretty much is the same stuff. It's just broken up into each part is a question on the quiz. They're all multiple choice. Let's look at number 2. A law firm claims that 56% of their new hires are women. Thomas believes that this number is too high. And after some research, he found out that the last 65 people, 31 were women. So he's not saying it's that 56 is too high for them, they should hire less. He's saying that their claim is too high, that they're not actually hiring 56% women. So the company says the probability, or the 0.56, he's saying, I think it's less than that you guys really aren't hiring that many women. We're going to do a 95% confidence interval, and so the last 31 out of 65, and again, this is a small sample size. Is that big enough for his proof? So is the 31 out of 65, which is 0.48. So they're claiming 56, and then the last 88 people that they hired, only less than half of them were women. So this is 0.48. Standard deviation. Always use that P number, 0.56, 1 minus 0.56, over the number in your study, 65. Five, 6, 0.0616, 0.0616, So then the z-score is p hat 0.48 minus p divided by your standard deviation. So we do 48 minus 0.56, 616, which is negative 1.30. That's negative 1.30. Since we're at a 95% confidence level, our alpha is 0.05. Right, it's the rest. So if your p-value is under that 0.05, you can reject the claim. So that, again, back to the calculator. Already have normal distribution, negative 1.30. And that is 0.09. So that is not less. So you fail to reject the null hypothesis. We do not have evidence that their claim is false. Remember, we can't prove that it's true. We can only prove that it's false, and we failed to do that. Doesn't mean it's true. Does that make sense? Nope, just a regular old day. Next week, it's early release. A confetti popper manufacturer claims that only 2% of their poppers are defective. Kevin wants to find out if that number's too low. So they're saying, hey, the chances of our poppers being defective is only 2 out of every 100, right? He thinks that that should be greater than 2%. So he goes out and buys 100 confetti poppers and finds 5 of them. So 5 out of the 100 are defective. So his p hat is 0.05, is 5%. Standard deviation, that's that square root. 0.02, 1 minus 0.02 over the 100. That I need a calculator for. I can fix this, 5 out of 100. 0, 2, 2, 100. That's 0.014. So then your z-score is p hat minus p divided by the standard deviation. 0.5, 0.2, 1.4, 2.14. Does Kevin have evidence to show? Oh, it doesn't say. I should have put a confidence level in that one. I need to fix that. So we'll just do another 95% one. So since it's a positive z-score, when you do the normal distribution, make sure that you put it in the minimal. So no maximum. The minimum would be 2.14. That's 0.016. 0.016. Remember, that's normal. Distribution 0, 1 with the 2.14 is the minimum and the max is infinity. So this is 0.01 is less than 0.05. So we can reject the null hypothesis. Their claim is false. Based on his findings, they are producing more than 2%. Statistically saying that this 5% on this big of a sample is not just a once happened by chance kind of thing. Question so far? So H of A is what the claim is. So like the drug manufacturer claims that 10% of patients who take the new drug experience nausea, that only 10%. So the HO, which is the null hypothesis, is always equal. The probability is equal to whatever they claim, 10%. Alternate hypothesis is whoever's doing the study saying this is too low or too high. And he did 200 patients, 38 out of the 200 experienced nausea. So that is 38 out of 200, that's 0.19. So he thinks this is too low, that their claim should be greater than 0.10. And remember, always in those hypothesis statements, those numbers are always equal. They're the same number. First one's always equal to, and the next one's always less than or greater than. So that's P hat from his study. So again, that square root, use their p-value, 0.10, 1 minus 0.10 over 200. .0212. And your z-score is p hat minus p over the standard deviation. So 0.19. 212. 425. 4.25. The alpha value for this one, since he wants to do it at a 99% confidence level, that means your alpha is only 1%. So the bigger the confidence, the smaller this area is going to be. So now you have to be less than 1% instead of just less than 5. This was 4.25. So now you're going to do your normal distribution with 4.25 as your maximum, or as your minimum, since it's positive. 4.25 And that area is extremely small, 0.000 something, right? 1, 2, 3, 4, and then a 1. So yes, that we will reject the null hypothesis. The drug, don't do drugs, manufacturer is lying, making a false claim. It is more than 10% based on this findings. Redundant, doing the same thing over and over. Uno mas. The drug manufacturer is lying. All right, last one. City council claims that 78% of eligible citizens approve of the new bond. So he is saying that the proportion is equal to what? 0.78. A newspaper believes that is too high, so less than 0.78. So she randomly talks to 500 people and found that 372 out of 500 0.74. Is that right? Let's try that. Let's check my bad math. 372 out of 500, 0.74. Well, if it's out of 1,000, right? So I just doubled that number. Because that's 744. That's the same as 744 over 1,000. And then just since it's 1,000, you can move the decimal 3 places. So then p hat would be your 0.78, 1 minus 0.78 over the 500 people, 0.0185. So your z-score would be your p hat 74 minus the claim 0.78 over that standard deviation 0.185. So it's a negative 216 z-score. So I would put it in the maximum since it's negative. Negative 2.16. So our p-value is 0.0154. 0.0154. And since we want a 99% confidence level again, this is just, so is the p-value less than the alpha value? No. So we fail to reject the null hypothesis. And then, so we knew P was 0.74. 0.0185 is the standard deviation and negative 2.16. Yeah. So